Hello and welcome to Re-enthused. Today we are going to take another look at the sword. We're going to kind of do a kind of rush job on this one. We've got the components that we need, thanks to Yossi on Twitter for helping us with some of the values. So what we're going to try is we're just going to try powering this up, and there's a lot of unknowns still with this board. But I think we should at least give it a try. Yes, I think most of this video will just be reassembling the machine and then just doing a smoke test, and we'll see what happens. Okay, so yeah, as we said, it's been a while since we've been on the sword. We had a brief respite while we dealt with the sharp, not because we didn't want to do the sword, we want to get this running, I definitely do, but because we literally run out of some ideas on some stuff, and we were trying to figure out mostly what these two resistors up here were valued at, and we weren't really getting anywhere, to be honest. And then we had a bit of an internet hero in the same shape of Yossi on Twitter, who very kindly took apart their machine and got the values for us. So those two resistors are 10 ohm resistors. There we go. So recommend these guys, by the way. Very good, very fast as well. So we can replace those with those, and relatively sure that the tantalum there is 4.7 UFs. Relatively sure it was also burnt up, and the one on Yossi's board is a different colour entirely. So I think that's a slightly different revision, but we're sure it's going to be fine. We'll probably find out quite quickly if it's not. Right, so I think what we're going to do is we're not just going to replace that tantalum, we're going to replace all of the 4.7 UF ones, because tantalums, they tend to, once they start going, they tend to go. Yeah, there's a few on here. This will also be the first bit I'm recording with my new lapel mic. I don't know if it's working, so this bit may actually just be the camera audio. We'll find out. And I will record my intro, but the intro will be recorded afterwards, so I will, in theory, know if this has worked or not by the time I record the intro. But anyway, let's get let's desolder some of these tantalums, resolder in the replacements, and put in these resistors as well. Right, with all those in, there's one more thing we have to do. There were two bodge wires coming from these resistors, two parts on this board. I guess we'll do that after we put the board in place, because it'll be easier. Right, let's get this board in place. And this solders in effectively like a kind of pin board, really. So, where are we? Oh, there we are. It's right in the middle. Literally in the right place. So we do this bit facing upwards, and then we just have to align these pins here. Like that. So they're all through. So now we have to resolder those in, and then take a wire from each of these resistors onto points on this middle part here. So let's just resolder all that back in for now. Alright, so Now that we have put that board back in, before we clean it up, let's work out where these wires are coming from. So from the rightmost resistor, that's going to this pad right by this block here. So let's do that one first. I'm just going to use some wire wrap cable for that. The original wires were quite thin, so that was putting much current through. There we go. That's not the neatest thing ever, but it will do. Right, that's all together again. Everything is plumbed in, so the next step is to literally put this back into the case, although we will clean this up a little bit before we do that. But we'll be back after we start putting it back together. Alright, let's get this back together again then. So this all kind of fits in fairly easily. These bits are connected to the back for the ports are the hardest thing. But then once you get those through, it just kind of sits on metal rests. Let's get these out of the way. There we are. And so once that's lined up, there we are like that. It's all kind of easy at that point. Now just remember where we put the screws. Alright, so let's screw it back in place. Obviously, yes, you could say this may not work all, but we're missing several components to getting this thing truly shipshape, most especially a service manual. But I still think we can do a smoke test today, if for another reason to see if those tantalums go again. So we're going to go for a smoke test. Now, normally when we say smoke test, we've got a reasonable idea that it's going to be all right. That, you know, it's probably going to work, or at least not fail significantly. I have none of those guarantees with this machine because, yeah, I'm not sure how it's supposed to react in several different ways. Now, I'm relatively sure I've replaced those components with the right values. Again, there's lots of weird models of this, so it's hard to be sure. The values, I would say, seem okay. There is a route to ground from live, but there's a fairly high resistance around it, so that's probably normal. Probably. I can't be certain. Other than that, we don't know, really. We've tested what we can test. All we can do is turn it on. As always, be careful with your own equipment. Don't follow these guidelines for this thing. If you can find a service manual, that's always the best way, and you can find a route. If you can't find a service manual, find a forum that'll help you. I failed to do either of those things on this machine for various reasons. But yeah, try your best to do those things rather than just turning stuff on. With that said, let's turn this thing on. We have lights, we have smoke. Right. Okay, so a resistor immediately gave out. That's kind of fun. So that's interesting. So that resistor immediately blew. So we need to find where that's coming from and why it's doing that then. Right, well there you go. We still have quite a bit more work to do on this then. Interesting. It's only that one resistor as well, whereas of course both of them blew last time. So I wonder why. And what's feeding that resistor? It could be still another bad tantalum. We haven't managed to replace them all, so we should possibly think about doing that. Kind of wish I'd found a better way of attaching that board and soldering it back in, really. That would have been handy as well. Oh well. We still have some work to do on this board. It's interesting that resistor died. We need to investigate that. We can work out where that's getting power from. And yeah, and try to find out why it's getting too much, or too much draw, or whatever it's causing that. Oh, that was fun. The room now smells a lot. I don't really know what that board does. It says it's PLL, which is generally refers to logic. So interesting. There's all those dials at the front as well. Maybe they're off. I mean, this is it. There's so many unknowns with this machine, and I really do want to get it working there. And we will. We will get it working. It's just there's going to be a few more tries yet. Anyway. Oh, that's all we can do for now, I think. Right. A fairly dramatic end to this episode. Yeah, I mean, there was always a chance something was going to happen. Unfortunately, there's so many unknowns on this machine, as I said at the beginning. I'm still suspecting tantalums, just because that appears to be mostly what's feeding that resistor. We will trace it back. We'll work out what that resistor is actually being affected by. But yeah, it's there's definitely something not quite right. I don't think we've re-affected anything much. I think that's probably, that resistor has probably broken the chain very early on. And we still got red lights on the board, and the lights had changed as well, so something else was being picked up. So, yeah. We'll have to take another look. Right. Well, thanks for watching. If you like the video, please hit like. If you really like the video, please hit subscribe. If you didn't like the video, or you have something else to say, then please leave it in the comments below. And don't forget to hit the bell icon so you can be reminded of episodes, including the next one, this sword one, where we'll start tracing back what that resistor is actually doing. See you next time.